Okay, so this part talks about points of inflection. Interestingly enough, though, it also says justify. So this is going to be quite interesting. We've got the sketch here. So look at this particular point of inflection here. We know that at this particular point there's a change in curvature, so we know definitely the second derivative equals to 0. Now that's actually a necessary condition, but it's not sufficient. You don't just find this condition and say, I've definitely found a point of inflection. We have to backtrack and just check to see if it's not a kind of stationary, like a local maximum or local minimum. That's quite interesting. So if you look at this particular section here, how do we confirm whether the point we found is a point of inflection? Well, we can either look at the first derivative, and if we substitute a point just before b, we'll find a positive gradient, and after b, we'll find a positive gradient. Basically, the gradient's heading the same way at a point of inflection. Even if it was a stationary point of inflection, like this, at the point here the gradient is 0, but then before the gradient is positive, after the gradient is positive. Yeah, so we can check the gradient before is positive, the gradient after is positive. So we can just check on that. So let's try that. Let's solve for the second derivative equals 0. So we're going to solve, we've already got the second derivative from the previous part, so we're just going to solve that equal to 0. So I'm going to factor out straight away 3e to the 3x. That's going to be 1 plus 3x plus 1 equal to 0. And as from last time, this can't equal 0. This is always greater than 0. So we're solving this equals 0. So that leads us very quickly to x equals negative 2/3. Very quickly we'll find the y partner. And the y partner is negative 2/3 times by e to the 3 times negative 2/3. You can see the 3's cancel. So this is negative 2 over 3e squared. So we've just got to check to see, well, we've got to justify whether such points are point of inflection. Okay, so we're just going to look at a little sign diagram here. So this is x is negative 2/3. I know there's an interesting point that x equals negative 1/3. I'm going to put a little value of a half in here, and I'm going to put a little value of negative 1 in here. And this is going to be, I'm going to do a sign diagram for f dash of x, because I've got f dash of x here, and it's just a bit easy to manipulate. So this is a sign diagram for f dash of x. Okay. So if I feed in negative 1/3 into f dash of x, I know the value is 0. And that's what marks that out as that local minimum. When I feed negative 2/3 in for x here, then I'm going to get e to the 3 times negative 2/3, that's e to the negative 2. Then that'll be 3 times negative 2/3 plus 1. Cancels out. This is e to the negative 2, and this is negative 1. So the answer is negative here. So negative 2/3, I've actually got a negative. So if we have a little look at this particular diagram here, I want either positive here, or I could have something like this happening, negative, negative. So let's go and check what happens when I substitute negative 1 in here. Well, you can probably see that negative 1 in here times 3 is negative 3, plus 1 is negative 2, so it's negative here. If I feed in, that should be negative a half into here, well 3 times negative a half is negative 1.5, plus 1 is negative 0.5, that's negative here as well. I really don't want to have that. There we go. So this is showing us that we actually have this situation. By the look of it here, we've got the gradient's negative, the gradient's negative, the gradient's negative. So it looks like if we go back to here, we've got a point of inflection here, which is kind of downward curving like this. So that would be enough justification. You could go and try and substitute it in the second derivative, and then you'd try and find actually a sign change around the value here. So if you had the second derivative you were checking, f double dash of x, and you were checking again negative 2/3, just after is negative a half, just before is negative 1. Well, we know when we feed negative 2/3 into the second derivative, we get a value of 0. if you feed in negative a half and negative 1, you're looking for this particular shape here, negative and then positive, or a positive then negative.